Welcome to Easy Solver. Today our topic is disk architecture from operating system. The same question can be asked, that disk architecture can be asked in operating system also, usually in the 5th module, and it will be asked in the subject computer architecture also. So, and it is a very important question for GATE exam also. Some small problems they will ask from the disk architecture part. So we'll start with the architecture and we will end with the problem, frequently asked problem in the competitive exam as well as in normal regular semester exam. So in real life, disk or hard disk, whatever we get, that will consist of some concentric platters. Concentric means what? See, let us take 4 platters, 1, 2, 3 and 4 platter of equal size, and through the center one spindle will go. Through center of the all platter one spindle will go. So this is nothing but spindle. Spindle is nothing but the axis by which that disk platter can rotate. So in real life, when we will see the disk, we can see all these 4 are very compact to each other. We cannot see them separately like that. Here for easy understanding, we have drawn it with some gap. Okay. So this is a platter whose both the side we can write something. If I take this as a individual platter, from this I can tell you, in this upper side also we can do read write operation, whereas the lower side, upper and lower, both the side we can do read write operation. So who will actually do read write operation? There will be some read write head. There will be some read write head which will move left to right. Like there is no movement of read write head from top to bottom. It will not move from here to there to there. Okay, or it will not go from upside of the plate and downside of the plate. It will there will be 2 read write head present for a particular platter. One will be in the upper side of the platter, one will be in the lower side of the platter. So upper side platter will, read write head will write the upper side of the platter, and lower side read write head will be writing to the lower side of the platter. Now so if the writing or reading operation is allowed in both the side of the platter, then 2 read write head will be there. For some specific disk, read write will be restricted to one side. Like only one side, downside or upside, we can read or write operation we can do. For some disk, what happens? Top of the topmost platter and down of the last platter will not be used for writing and reading. Remaining all, like these 2 upper and lower we can write. This down part we can write. For this up part we can write. As of now, we are assuming all 4 our platters are consisting together a complete disk. We have read write head which will move only through left and right side, and all the read write head will be joined to a stick like structure which is called actuator arm. What it is called? Actuator arm. Arm is nothing but a hand which is holding 2 read write head for writing or reading in the upper and lower side. Now so what we got is platter, then we got the surface. Surface is present both the sides of the platter. Each surface is divided into some tracks, and each tracks are divided into sectors. So if this is a platter, I have just taken a single one. If this is a platter, it is divided into some platter surface is divided into some tracks. These are called tracks, concentric tracks. Here if I draw, it will look like that. And similarly, it is for this also, for this also, for this also. Remember, it is concentric. So if I have 4 here, 4 tracks here, I will have 4 tracks here also. I will have 4 tracks here also, as well as here also. all the tracks are divided into some sectors. So from the center, if we draw some lines, this will be sector. So you can see, if this, I am giving the name of this as sector 1. Let's say this is my sector 1. So sector 1 covers all the tracks. If this is track 0, track 1, track 2 and track 3. 1, 2, 3, 4 tracks we have taken, and we have taken 1, 2, 3, 4, 5 sectors. So each sector, this portion is nothing but a sector. This angle is nothing but a sector. So each sector covers portion of all the tracks. All the sector covers portion of all the tracks. Okay. Now read write head, how it writes? It writes in the 0th track, then track 1, then track 2, then track 3. Again it goes this side and writes to this track, this track, this track, this track. So for a specific sector, track wise reading writing will be performed. Then disk will rotate. This disk will rotate. Then this sector will come in front of read write head. Read write head does not move. Disk rotates. So first this part is in front of read write head. When disk rotates, this part will go in front of the read write head. See, this part is first in front of read write head. When disk rotate to this direction, this part of disk will go in front of read write head. So in that sector, the writing will be taken place. So like that, reading and writing happens. So track is divided by sector. Every sector there will be data present. So data will be sector wise, data will be present. Every sector, suppose we can tell every sector we have 512 byte data or 512 KB data or megabyte data, like that we can tell. So this is the overall structure of a disk, and that rotating thing, rotational latency, all those things we'll discuss in the next video. As of now, we'll discuss some problem which will be asked in usually exam in or competitive exam. First question what will be asked is, what is the size of the data for a particular disk where the number of platters, surface, track and sector and data will be given. So let us first discuss with the problems what will be. We are assuming that we have number of platters 4, each are having 2 surfaces. Number of tracks present in each surface is 512. Sector present in each track is 512, and data we have present in each sector is 512 KB. So if you want to find out the size of data, that will be calculated with the multiplication of all those things, like how many platter, how many surface of that platter, how many tracks, how many sector, data per sector. So usually we will represent all those things in the power of 2. So 4 means 2 to the power 2, 2 means 2 to the power 1, 5, 1, 2 means how much? 2 to the power 9, 2, 4, 8, 16, 32, 64, 128, 256 and 512. So 2 to the power 9. Similarly, this is the sector. So this will be equals to 2 to the power 9. 512 KB. 512 is equals to 2 to the power 9. But KB how to change? See, we know 1K equals to 2 to the power 10 byte. 1 mega equals to 2 to the power 20 byte. Giga similarly 2 to the power 30, and tera equals to 2 to the power 40 byte. So here what we have is kilo. So we will take it 2 to the power KB. If we convert to byte, it will become 2 to the power 10. So if we calculate 3 9s are 27, 28, 30 plus 10. So 2 to the power 40 byte. 2 to the power 40 means tera. So we can write 1 terabyte. So size of the data will be 1 terabyte. One more question will be asked. So hope it is clear. Platter, surface, then track, then sector and data. All the values will be given. size of data is nothing but the multiplication of all, and while multiplying we should take all the values into the power 2 to the power something format, 2 to the power x format, and always the value will be given in such a way that we can express it in terms of 2 to the power. So there is no confusion. They will not give us a value of 513 or 514 like that, which cannot be expressed in terms of 2 to the power x. Okay, so the next question what will be asked is number of bits required to represent the disk. So if we try to calculate number of bits required to represent the disk size, it will be nothing but 40. It will be nothing but 40. Why it is 40? Because we know, see, for representing 8, how many bits we need? Into the power of 2. See, 2 to the power 3 equals to 8. So represent 8. How many bits we need? We will always tell 3. This is 1 plus 2 plus 4. See, if we want to calculate what is 8, what we will tell? When we are taking 2 to the power 3, no need to take that 1 and all that much representation. We will take 2 to the power 3 equals to 8. So how many bits are required to represent 8? 3. So similarly here it is 1 terabyte. So 2 to the power, how much is there to represent the value of size of data? How many bits I required? 40. Here it is 8 and here it is 2, here it is 3. So 3 bits are required here for 8. We know it very simply. Here what we will write is 40. So number of bits required to represent the disk size will be 40. So what we need to do, we have to take this value, we need to calculate that. Then what will be the power of 2? That only will be the number of bits required to represent the disk size. Thank you for your patience. If you like, please subscribe the channel.